we have no sound. Corporate network, V6, whatever.
На самом деле, мой слайд — такой комикс по мотивам документа, который сейчас только что прошел отдел
Better. So, my slides are a kind of a cartoon comics, so I suggest you read the comments. Will be clearer than my slides. What are the specific requirements to connect to the corporate networks to IPv6? Such networks, as a rule, use addresses allocated to them by the operators. Most often, a corporate network does not have a resource or desire to stop. They can use PI addresses. If they want to have more than one internet connection, but PI addresses, I think, is not the best solution globally, because we hardly want to see every little shop as 148 routes. I don't want, because you need to buy routers. Besides, PI means PGP, and a small network may not have a technical capacity to use BGP. I saw cases when small operators would just set up static routes. All you can do, especially in remote areas. I don't even want to mention NAT, NAT, so we don't want to lose end-to-end IPv6. And I would like to have at least a tactic solution that does not require some changes, because there are so many old cell phones and laptops and waiting for 5 to 7 years until some new solutions will be loaded onto those devices would be rational. So let's start with the problems to address in the corporate network who wants to get IPv6. First, you need to send packets to proper uplink to operator, the owner of the address of the packet sender. If the address with the A address will go to the B operator, the B operator, if he's a bona fide good, will block this packet, or uplink will block it. Anyway, you need to send the packet with the address value of the source. Sometimes you need to apply some policies and to describe one uplink as the main and the other as a backup. What do you do when the uplink falls or goes up? When the uplink drops, you shouldn't send packets to this uplink or use as the source addresses the operator's addresses, because first he'll not send, or if they go to the internet via another operator, then the traffic will not go back to the original device. If an uplink dropped and host stopped using the addresses of the operator, when this uplink is back again, hosts need to know that this uplink is again available and the address space is available, and you can use those addresses as source addresses. As for uplink selection with the sender address, source address, now there are solutions, and some solutions are still in development. First, we have policy-based routing. Not very elegant, but it works, especially in simple topology. The more complicated the topology, the harder the use. And now, source address dependent routing is now in development. It's virtually creating several routing tables that are specific for one block of source addresses. IPv6 segment routing can be used for the same purpose. I don't even want to talk about sending packets to the necessary uplink because there is a solution for that. As for the proper source address, considering availability of which uplink. So the question is, are there any technologies to address this issue? First, it can be addressed at the transport level. For instance, MPTCP can respond to having some path available and switch to another source address. Quick. Work is now ongoing on multipath support in QUIC protocol, but unfortunately, the world is more complicated than TCP and QUIC. We would like to have a solution working for all the transport protocols. ITF now working on a beautiful concept of multi-provision domain that addresses the multi-home host problem in general, but unfortunately this is a new technology and it will be available in quite a while on most of the devices. We would like to have some technical solution. Meanwhile, right now, because I know corporate network that required multi-homing yesterday, and they need something that will let them wait for the multiple provision domain support on most of the hosts. So at some moment, watching this problem, trying to address it in general, there is an abstract corporate network with a connection to operators and topologies and use cases. We see that it's not easy without use of the multiple provisioning domain. But what if we try to narrow down the goal and address specific task that would still cover most, well, not most, but popular scenarios of corporate network that has 2 internet connections, maybe 3. But I haven't seen it in real life, and these connections would be used for internet. We are not considering walled garden when operators have resources available only from the operator's network. Then, speaking about simple network topology, small corporate network, we're not talking about data centers, just the network that wants to go to the web. Like this. There is a corporate network with connections to green and the blue operator, 10 whatever users with the telephone. So the telephone gets 2 addresses, blue and green, and wants to go to internet, Facebook, and watch kittens. Kittens videos. Let's consider the problem that we need to solve here. What are the requirements to signaling and changes of topology to host? If uplink fails, address space of the operator should not be used. If there's nothing else, you can try, but if there are other addresses, better to use them. If uplink is back, the host needs to use them again to connect to internet. If one of those uplinks is main or primary and the other is reserved, so backup, then the policies may require that the backup operator shouldn't be used if the primary uplink is up. So these are the 3 or rather 2 rules, speaking about the load distribution between the channels and main topology. It describes the internet connection of a small corporate network. And actually there is a mechanism, a tool in IPv6 that does what we want. That's called
some
configuration that's compulsory for support on all hosts. It's the key in IPv6, and you don't need to add anything to the host. When we say the address in this block, in the operator's block, can be used, it means that this address on the host has preferred lifetime parameter or higher than 0. When the router sends the packet to the host, then it can include one or several prefixes that are available to configure IP address on the host, and the host will create IP addresses in those 4 blocks. And each prefix in this case has a primary value, preferred lifetime, and when the host creates an address, would assign to each address to the value of preferred lifetime, and then the counter will start ticking and reducing the preferred lifetime. And when the host gets the new prefix, he will just turn the counter to 0 and starts counting again. If the prefix should not used, Slack allows you to signal, to let know about it by sending the preferred lifetime equal to 0. This is is used actively in every case, so you cannot change one network /64 to another without sending to all host a router advertisement with information about the prefix and preferred lifetime 0. In this way, it looks like we can use Slack for signaling to hosts about availability of the uplink or unavailability. The failure, uplink failure, means that the router should send to all the hosts router advertisement with information for this prefix and prefer lifetime 0 equals 0, which will immediately transfer all the addresses to the deprecated, and the host will not use them. When uplink has recovered, the router should send RA, router advertisement, with preferred lifetime not equal to 0, some default value that in most cases is around 7 days. If you look at the topology with the primary and backup uplink, it means that until the primary, while primary uplink is functional, the routers will send information about the main prefix not equal to 0, higher than 0. And for the backup uplink, preferred lifetime is always 0, and while the primary uplink is up. When it falls, so the router will send information about the backup prefix with the value of preferred lifetime higher than 0. Then they will use this prefix. I don't know if I made it clear. Let me show you the pictures. It is very similar to the existing ways to describe the policy in the routing and VRP. What would we like to get finally on the router? Now we just describe the prefix on the interface and use the default lifetime, but we would like to say that if some conditions apply, then we use preferred lifetime higher than 0. And if the condition is not like that, then the preferred lifetime equals 0. And when some event happens on the router, it should trigger router advertisement sending. It's an interesting thing, because even now, if the routing package, they can change prefer lifetime from not 0 to 0 and keep the configuration, save it. Some routers will not immediately send router advertisement to host. Some routers believe they just have to wait for the next programmed events on sending router advertisement that may happen in quite a while. What do we mean by events in this case? It's difficult to describe clearly, strictly, the conditions when interface is functional to operator. So the simplest way is that when the interface is up, then uplink is functional. If it is down, then uplink is not functional. So it's not always the case. Interface may look active, but the traffic is nil. And depending on the topology, complicated or not, and reliability of uplink, we can speak about a route. For instance, if the operator supports dynamic routing, or speak about the results of some test packet sending, like Juniper has a chance to send packets straight from the router and signal about the situation when the packets failed to deliver. What are the fields in the router advertisement we would like to change if an event happens? First, preferred lifetime. I told you it's an opportunity to signal of availability of the host. And then, if the host get DNS information through the router advertisement, probably it would be nice to signal that DNS of the operator is unavailable, and so on. In more complex topologies, when you use two routers for two providers, and would like to change lifetime router by default. So if, say, one A operator is connected to A router and B through B router, then if A uplink fails, so no packets should be sent to this router, and this router should not be the default router. I think the picture will make it clearer, worth 1,000 words. We have a scenario when a simple corporate network has one router connected to two operators. One router may physically more than one device. It may be a cluster with whatever firewall. And we have the green block for green operator, blue block for blue operator. Host has two addresses, and as the policy says that the blue operator is the backup operator, we don't want to use it until the green, unless, well, the green operator fails. So the router will be sending to router advertisement information about the green prefix with preferred lifetimes higher than 0, and to the blue equal to 0. So at the host, in a normal condition, when the main uplink is up, the green addresses will be preferred. So they will be chosen for the new connections, and the blue addresses will be deprecated. So they will not be selected for new connections unless while the green addresses are available. So simple policy: if the green uplink is functional, then the green prefix preferred lifetime not equal to 0, or in the opposite case is 0. And for the blue is the condition is the green uplink condition. So the blue addresses should always be deprecated with the preferred lifetime equal to 0 until the green uplink fails. If the green uplink fails, For instance, someone cuts the cable. Then the router, after this event, immediately will send router advertisement whereby with the information about the prefixes changed. Now the green prefix has preferred lifetime 0, and all the hosts immediately change the green to deprecated and start using the blue addresses because they become preferred, and the router should keep sending router advertisement with this information until this condition does not change, until this condition changes. So this is change of configuration of the router. If we have two main uplinks, primary uplinks, and we speak about a simple situation when you have two uplinks and use them at random, both prefixes are preferred and lifetime not equal to 0, and the router will send RA, and the host may use any address at its discretion according to the default address selection algorithm. If an uplink fails, as we told you, it is a reason for the router, a trigger for the router to change the prefix to 0 and signal to all hosts to make sure they don't select this address if there are other preferred addresses. So, with a more complex topology, we have a more complex algorithm and the logic of the policy. If we have two routers, one for connecting to A operator and another for B operator, and say the green operator is a primary blue backup, and how do you describe on the blue router the fact of the green uplink drop? One of the ways is a special chart or table for the uplink interface. If the interface drops, then the route disappears. As we see here, uplink to the green router, green ISP, failed, and the other router, the blue router, discovered there is no green route for uplink and sends preferred lifetime with the valid value to the blue prefix. In case of two active uplinks, we don't need to deprecate the blue prefixes. If we have the green uplink, it's simple. Each router will send RA to its own block of addresses. The first router will send RA to the green addresses and the blue for blue addresses. In this way, initially, again, the host has two addresses, blue and green. Actually, it's more than two, but it will have addresses in green or blue block, and it can choose any with the default address selection algorithm. And then, if an uplink fails, the relevant router deprecates this prefix by sending RA with a preferred lifetime 0, and the host starts using the blue route. Then, if you have dedicated router for operators and the host has some dedicated router by default, in this case, it will only influence the description of the event. And now it's better that you use dynamic routing and tell about the uplink failure. And if the operator has dynamic routing, it will be best to use the routes. So, etc., etc. Yeah, use your imagination. The main thing I want to convey, this is a tactical solution, and catering for some specific scenarios of small network without any specific requirements on the access to them from internet. So, What's there to
отличие
add?
от решения,
So
которое
unlike the
применяется сейчас
solutions
для IPv4,
that we
когда
use
просто
now for
делается мат на
IPv4, when you just
адреса оператора,
use the operator's
когда
addresses,
uplink падает, разумеется, и в том и в другом
not.
случае, в случае
When the
вычисления
uplink
шесть,
fails, in
существующая
both
сессия
cases,
обваливается
the
просто потому, что
sessions
нет
will
обратного
drop
маршрута
because there is no
на
reverse route
эти адреса.
to those
Тем не
addresses.
менее, когда uplink
But
к
when
оператору
the
поднимается
uplink
опять, в случае
recovers,
V4, скорее всего,
in
у
case
вас
of
существующая сессия опять порвется,
IPv4, the sessions will
и произойдет
fail again
переключение на
and
основного оператора.
switch to the main
В
operator.
случае V6,
In
поскольку хост
V6,
все еще может
as the hosts
использовать
can still
deprecated
use deprecated
адрес,
address,
эти соединения
these
останутся жить. То есть,
connections
на самом
will
деле, в случае
remain
V6
alive. In case of
предлагаемое
V6,
решение
the solution
помогает,
will help
работает лучше, чем в
and
случае
works
V4 с точки
better
зрения
than
сохранения
V4
состояния
in
существующих
keeping
соединений
the status
в
of the
случае
existing
подъема,
connection
например,
in
основного
case of
уплинка с
recovery of the
основной
main
карты.
uplink.
Некоторые
Some
люди, услышав про
people,
предлагаемое решение, хватаются за голову,
when
начинают
hearing
говорить,
about the
что это
solution,
очень
start
сложно,
running around, say it is so
совершенно странно,
complicated, it's so
бесконтрольно
convoluted, strange use
Я
of
хочу
router.
сказать, что мы
I
вообще не
tell
говорим
you
о
that
чем-то
we're not
новом.
talking about something new.
RFC 7084,
RFC
который описывает требования к IPv6 и TPE, и все эти
7084
коробочки, которые мы ставим себе
that
дома.
describes requirement even to the
Явно
boxes we put at
требует,
home requires
что
that
маршрутизатор
the router
должен
should
явно сигнализировать
certainly
хосту,
signal to the
когда
host
префикс
when the prefix
перестал быть
PO6
доступен
stops
для плинка
or fails.
Точно так же себя ведут, например,
So
маршрутизаторы,
that's the behavior of the
которые
routers
поддерживают технологию
supporting the HomeNet technology.
Если
If
оператор
uplink to the operator
упал и был недоступен,
fails
они
and
явно
unavailable,
сигнализируют
they
хостам
signal
о
to the
недоступности
hosts
своего
about
префикса.
unavailability of this prefix. So what is
Перенос вот этой технологии
suggested
с
here
домашних
is the
маршрутизаторов
switching
также
of this technology from home router to more controlled network of small corporate network.
Возник вопрос, как же все это
So you
сейчас
probably have a
настроить?
question. How do
Куда
you set it
писать,
up?
какие команды
Where
выбирать,
do you run?
версию
What commands you should type in? And
состояния.
what is the DNS you should
Ведется
install?
работа с вендорами над тем,
Now we work
чтобы
with the vendors
можно было явно
to
в конфигурации задавать такие параметры.
to be able to set it up while we are waiting for the vendors to put it in. In fact, you can do something now. I did it on Juniper using event policy script. So the opportunity to change configuration after an event. So the simple case that works well on changing the interface status to configure this interface in the router section. And there's a plan for some scripts. You could try how it works in this scenario. And again, it doesn't work for very complex networks. In this case, you target the networks who don't want to use HomeNet and uncontrolled environment because they already use some standard vendors, Juniper or Cisco. On the other hand, they want to have this functionality. And I guess that's all for today. It's not that I had in the draft. I didn't have enough time to speak about the situation when the link fails and then recovers. So it's all described in the document from the first slide. And I still hope we have Q&A, time for Q&A. I thank you. Yes, we have time. I can see the first hand. Jeff, yeah? Yeah, hello. The draft is just ready, and she needs 15 minutes. I have just flew in. Yeah, I was recording the video. I'll clean it. So the draft will go through the last stage to become valid. Right, good. Some best practices.
Any more questions? Anyone wants to have anything else to say? Anyone has anything else to say before we finish? Gusev Alexander, St. Petersburg. You started with the practice that you don't want to wait for 5 years, and so what magical post with 2 IP addresses will get them and will use them in enterprise? What are those 2 magical? I have a million of them. Those IP addresses. Maybe can you give us even IP4? There's only 1 address. Maybe just some kind of behind on the current hosts. So so actually it's one of the basic difference of V4, V6. All notebooks are in config, so there will be 2 global addresses from 1 prefix. If I have several prefixes, that's 2 ends at least. This is the standard behavior. So meaning that we are talking about kind of working notebooks, right? And so where it's easy and straightforward, especially if they're done for Linux. Now we're talking about all devices. All devices usually in the network. Certainly, I've seen only Windows, so only Linux. So it's very rarely, because I think that Windows, Linux, cell phones, everything, different operating systems. The good news is that recently NRA held a test how to implement default address selection to implement on the majority, and on the majority of devices it was implemented quite successfully. You mean device is the entire zoo, right? Not operating systems only, but cell phones, printers, right? That's what you mean. Everything that the enterprise has, right? Yeah, exactly. So the ones that need to get in touch with internet, because a printer is a specific case. The printer don't like lots of IP addresses, but on cell phones it works very well, better than on notebooks, than on tablets, because not only so everything is on VC only networks. So notebooks, some of them, some operating systems are just catching up only, so they don't work well, and much better they work in cell phones. Roman Peshihonov, so what you showed, so very educational and very broadening, but unfortunately enterprise will select the cheapest option. As I say, stateless, not 6.6. That's what private and addresses to translate without keeping the session in public addresses of isolated operators. So this is the cheapest and the painless option to wait for the bright future. What's your take on that? I think that all this story was born because there were some enterprises appeared. They don't want to use DAX 6.6, and it's not 6.6, not 6.6. Yeah, prefix translation. It's not 6.6, right? They don't want to use it. Yeah, and stateless translation. Yeah, and effectively, so the future will tell. And if there's no alternative, then no one definitely will be using. So if there is no alternative, then we'll understand so which way of development the industry will take, because we see so that there are several options evolving right now. And so questions, comments before we move over. Roman Sokolov, MTS Telco. I have more like a comment because my colleagues are launching a V6 on cell phone, and so then interesting picture that so the prefix delegation through LTE interface doesn't work that way, and so then other colleagues paid attention. The recommendation was ripe that in households when We need just to remove this IP6 static addresses. So the dynamics, so it will break, it won't work, and so what? No, wait. Because as far as I remember, there was this document of prefix delegation, RIPE prefix delegation. Yeah, so I'm excited. So prefix delegation, RIPE document, which participated in its development. So when you make a prefix delegation, when you make prefix at this stage, it is recommended to use the static prefix delegation, meaning just to give the same prefix to the same client. And the reason is that if CPE is overloaded or just or rebooted, then the system may not see that after reboot the prefix changed, and the system will not see it. And CPE should signal, should remember that there was only before reboot there was one prefix, and after reboot there was another fix. So that's why we need to deprecate that. But many devices don't do that. That's a recommendation, prefix delegation, which is dynamic in itself, that it's better probably to use static prefix delegation. In LTE, I don't know about CPE, but some mobile devices, they work very well, and they should do prefix delegation. So one thing, just let me get in for a second so that would understand the intrigue. So she is the chairman of the working group of IPv6 in RIPE. Right? And so what's the intrigue about? Because Roman was talking about the right recommendations, and that's exactly where the intrigue comes up. Okay, what I'm trying to say that enterprise is quite possible when Cisco during a jealousy and all lost connectivity. And the CPE. So there is another question that de facto. So the whole chain of active devices, so active modems, so that getting those prefixes as well, and translation of data, they do that when the network card breaks down. And so probably it's good that we have this draft, and so then we can just get more vendors and more just devices so that they would support dynamic system better. But it's not so cloudless and wonderful. No, it's not so cloudless, but the prefix delegation CPE, so then RFC it caught up already, and FCPE is not deprecated prefix after it has changed, and then it's a violation of the regulation, and we need just to refer to it as a bug. With the situation when in my draft, so more often than not, it's not prefix delegation, it's the situation whereby the operator said, so here's your C48/56, so live the way you like. That's it. So then I statically refer it, and then you do whatever you want with it. Unfortunately, I missed the beginning of the presentation. Did you have it in the beginning that in the router at the entrance, so this is CPP or it won't work? Why? Because every provider will be getting other people's packages. No, there were slides that, so we need to somehow send packages to the proper uplink, required uplink. It's very easy. Before ABR, if we want just modern technologies, that's CDR or just routing. And use your imagination. I think that we need just to wrap up our discussion. It is true that Zhenya is actively participating in IETF and RIPE's community, very head of the working group of RIPE, and she is involved in the work of IETF. So you can always join and ask about the development and evolution and the designer architecture, and so you can just participate in the relevant group, working group of IETF, and you can continue this presentation. Because the presentation is not just to give you a thorough understanding, but the main point is if you're interested, just hook up to this work. Because she has huge experience, and she's seen lots of installations, but not all of them, because I'm sure that you can always add the benefit of your experience of knowledge. You have something to say to her as well. Just so get involved if this is close to you and if you're interested, because this is something that we as organizers and program committee, that's what we expect from you. Any? Okay, any more questions or no more questions? Jeff, the last question, very short question. So then discussion of the draft and the routing working group in IETF, right? So you can read it, what was discussed, what comments. And that's we're ready, but if you have any more comments, if you have anything else to say, then that's...